Hello students. So today we are going to learn another method to solve differential equation. Okay, so suppose a differential equation which is a linear, that is of degree 1, is given in the form dy by dx plus py equal to q. Okay, so here you have to find the integrating factor. Okay, so P and Q are the functions of x, okay, or the constant functions. So first you have to find the integrating factor. Which is given by e raised to integral p dx. Okay, this is your integrating factor. And second, you have to multiply this integrating factor in a equation such that you will get y into integrating factor equal to integral of q into integrating factor dx. Okay, so in this equation you have to substitute your integrating factor, then you will get the solution, that is y. Okay, after solving this, so these two things you have to remember. And first thing is, this equation can be given in jumbled form, that is q is here and p is there. Okay, then you have to first rearrange the terms in this way. Okay, and then you have to identify what is p, what is q, then you have to find integrating factor. Okay, and then substituting integrating factor in this equation, you will get the solution. Okay, so this equation can also be given in another form, that is dx by dy form. Okay, then that time p and q will be the functions of y. Okay, so let's just write this again. Okay, here a constant of integration will come. Okay, so if it is in the form dx by dy, okay, plus px equal to q, okay, then your integrating factor becomes e raised to integral p dy. Okay, and your new this equation will be x into integrating factor equal to integral of q into integrating factor dy plus c. Okay, so accordingly you have to make the changes. So let's just take one example. Let's solve this. So first you have to get it in the form dy by dx plus py equal to q. Okay, so we don't want this x here, so divide the whole equation by x. Okay, so you will get here dy by dx minus 2 upon x y equal to x. Okay, so your p is minus 2 upon x, your q is x. Okay, so now you have to find the integrating factor, e raised to integral p dx. So e raised to integral p is your minus 2 by x dx. So e raised to minus 2 integral 1 by x dx, which is e raised to minus 2 log x. Okay, so this minus 2, this you can write it as, what is that, log of a raised to b, you can write it as b log a, right? So this is given in e raised to minus 2 log x, which is your e raised to log x raised to minus 2. Okay, So e and log go, and you will get the answer x raised to minus 2. Okay, which is 1 upon x square. This is your integrating factor. Now substitute that in y into integrating factor equal to integral q into integrating factor dx plus c. So y into integrating factor is 1 upon x square, integral q was over x, integrating factor is 1 upon x square dx plus c. So here 1x will remain. So the final answer is y upon x square equal to log x plus c. Okay, so this is the final answer. So you can write it in the form e raised to x square y 1 upon x square. So this is by x. Yeah, so this is the answer. This is the second equation which is given. Okay, let's just write it in the form dy by dx plus py equal to q. Okay, so I'm writing here y dx equal to x plus 2y square dy. So either I can write it in the form dy by dx or dx by dy. Okay, so I'm going to write it in the form dx by dy. So let's just write it. So dx upon dy y. So again taking this x this side and 2y I'm keeping that side. Okay, now dividing by y on both the sides. So we'll get dx by dy minus 1 upon y x equal to 2y. Okay, so your p is minus 1 upon y and q is 2y. Okay, since it is in dx by dy form. Okay, so integrating factor is e raised to integral p dy. Okay, so e raised to integral minus 1 upon y dy, which is e raised to minus log y. Okay, so this you can write it as y raised to minus 1. So we will get 1 upon y, that is y raised to minus 1, that is 1 upon y. This is your integrating factor. Then you have to substitute it in the next step. Integrating factor into y equal to integral of q into integrating factor dy plus c. So y into 1 upon y integrating q is to y into 1 upon y dy plus c. Y gets cancelled, so we'll get 1 equal to this is not y, this is x. Since we are taking now in terms of x, right, dx by dy, so we'll get solution in x. So this will be x upon y. Okay, x upon y equal to integral of 1 that is y plus c. So this is your answer. You can write it in the form in terms of x only, that is you can take this y this side, so it will be x equal to 2y square plus cy. So this is the solution. Let's solve this. So first you have to identify p and q. So this is your p and this whole thing is your q. Okay, so let's find the integrating factor e raised to integral p is 1 plus 1 upon 1 plus 1 x square dx. Okay, now if you can identify this is tan inverse of x integral. Okay, so this is in e raised to tan inverse of x. Let's just y into integrating factor, that is e raised to tan inverse of x equal to integral of q e raised to tan inverse of x upon 1 plus x square into e raised to tan inverse of x dx plus c. Okay, now I'm writing this e raised to tan inverse of x and e raised to tan inverse of x as e raised to 2 tan inverse of x. Okay, so I'm taking t as tan inverse of x. So dt will be 1 upon 1 plus x, right? Let's just substitute in this. So here the other part is like this. RHS becomes integral e raised to 2t and the other thing is dt plus c. Okay, integral of e raised to 2t is e raised to 2t divided by 2, a derivative of 2t which is 2 plus c, and then you have to substitute what is t, what we have taken, that is tan inverse of x. Okay, so y into e raised to tan inverse of x. This is the final answer. You can take this tan inverse of x here, e raised to tan inverse of here, so you will get the general solution, that is y. Okay,